A general factoring strategy. If you see a problem and the directions say factor, here's the steps you should go through. The first thing you always look for is a GCF. Take out the GCF first. Then what you do is you count. If there are only two pieces, you use one of the special formulas that we have. Difference of squares, sum or difference of cubes. After you take out the GCF, if there are three terms, then you have to see, well, is the first number a 1? If so, you can usually guess and check real quickly. If the first number is not 1, use grouping. But for both of these, look for that little shortcut that I've talked about in previous videos. Look for the perfect squares. Alright, you take out your GCF. If there are 4 terms, you factor by grouping. And in all of these cases, look to factor more. Okay, so this is where factoring gets complicated because there are a lot of different options and you need to be able to understand all of them. So let's take a look at number 1. Number 1, the first thing you should recognize is that there's a GCF. There's a 5 in front. Sometimes students will forget about the GCF and they'll say, hey, that's not the number 1. And they'll go to the grouping method and they'll do the 5 times the negative 15. And truthfully, that will work and it will give you the right answer. But it's a lot harder. You really want to take the GCF out first because it's going to make all your numbers a lot smaller and a lot easier to deal with. If I take out the 5, I notice I have x squared minus 2x minus 3. And then I notice that's 3 terms. I notice a is now the number 1, so I can jump right to my guessing method, where it's got to be an x and an x. And I think a minus 3 and a plus 1 will work. Alright, so taking out the GCF is not only the right thing to do, it also makes your life easier. It's easier if you take that GCF out first. Makes all your numbers smaller. Number 2, trinomial 1, 2, 3 pieces. Unfortunately, no common term, and unfortunately, that's not the number 1. I have to use the grouping. I multiply. 12 times negative 5 is negative 60. Can I break up negative 60 to make my numbers add up to be an 11? Let's see, how about negative 4 and positive 15? Those multiply to negative 60 and they add to 11. Okay, so I come back here, 12x squared minus 4x plus 15x minus 5. So basically what I've done is I've changed step number 2 where there were 3 terms, and I've changed it into step number 4 where there are 4 terms. So we use our grouping method. First group has a 4x, which would leave 3x minus 1. Second group has a 5, which would leave 3x minus 1. Again, self-built-in check. Those better match. If they don't match, you made a mistake. Write down those. 3x minus 1. Left over. 4x plus 5. Alright, continuing forward here. 1, 2, 3, 4 terms. So it looks like a factor by grouping. However, before I deal with the 1, 2, 3, 4 terms, I notice I have a GCF. I notice I can take, you know what, this problem has a mistake in it. This should be 4x to the 5th. Make that little change. That should be 4x to the 5th right there. Alright, so I can take a 4x squared out of everything. And then I'm left with x cubed plus 3x squared minus x minus 3. And then again, what I like to do, if I pull out a GCF, I like to write the 4x squared and then write my 2 sets of parentheses because I don't want to deal with that 4x squared over and over again. And then I'm going to come off to the side and factor this thing more. First thing I notice is I can take an x squared out of the first group. Second group, not a whole lot, but there's a minus, so I'm going to factor out the minus, and that becomes x plus 3. And I'm in good shape because those match. So that's x plus 3. And when I take that away, I'm left with x squared minus 1. So now I come back here and I fill that in. X plus 3, x squared minus 1. Be careful. Don't stop there. You can do better. X squared minus 1, that's square minus square. Final answer should be 4x squared times x plus 3 times x plus 1 times x minus 1. And this is where factoring gets complicated. Notice we had to factor 3 times. We took out a GCF, we factored by grouping, and then we factored difference of squares. So you've got to look for all of them every single time. You can't ignore one of them. All right, number 4. We should notice with number 4 that there is a GCF. I think it's 6x. That's going to leave me with 6x squared plus 11x plus 4. Once again, I think I can do better. And I notice I have a trinomial, and that's not the number 1, so I'm going to have to use grouping. So again, I like to write my little answer here, and then I'll come off to the side and deal with this. 6 times 4 is 24. Can I break up 24? Let's see. 24 goes 8 and 3, which add up to 11. So I'm going to have 6x squared plus 8x plus 3x plus 4. GCF on the first group is a 3x. I'm sorry, 2x. And that leaves a 3x plus 4 plus second group doesn't have anything in common. That's unusual, but that can happen. Realize you couldn't see some of what I wrote there. But it's okay, because notice the 3x plus 4's match. So I write down the 3x plus 4, and then when they're gone, left over is 2x plus 1. Don't forget that we write a 1 there. We're lazy. We usually leave it off, but you need it here. So 3x plus 4, 2x plus 1. Okay, now, once again, why do we do all this factoring? Primarily, we do factoring to solve equations. So let's talk about solving equations. First thing I recognize is it has an x cubed. That's okay. If I have an x cubed, I better have 0 on one side, and I do not. So I fix that first. Subtract 45 on both sides. 1, 2, 3, 4 pieces. No GCF, so we jump to grouping. Take out an x squared. That's going to leave x plus 5. Take out a minus 9. That leaves an x plus 5. And again, I'm very convinced I'm doing this right when those match, and they do. So I write down the x plus 5. Left over is x squared minus 9, and it still equals 0. One more time, I can factor because this is a square minus a square. So x plus 5, x plus 3, and x minus 3 equals 0. Not surprising, I started with an x cubed. I'm going to end up with 3 answers. X plus 5 is 0, x plus 3 is 0, x minus 3 is 0. So my 3 answers are x equals 5, x equals negative 3, and x equals 3. Okay, very typical example of having to factor multiple times. Factor by grouping, factor difference of squares. Next one, trinomial, no GCF, multiply the ends. 12 times negative 2 is negative 24. That looks like a positive 8 and a negative 3 to give me the 5 in the middle. So 12x squared plus 8x minus 3x minus 2 is 0. GCF there is a 4x, leaves 3x plus 2. Since that's a minus, we're going to take out a minus. And we've seen this happen before, really nothing common there. But because we take out a minus, the sign in the middle changes. Those match, so we write it down, 3x plus 2. Left over, 4x minus 1. So we would have 3x plus 2 equals 0. 4x minus 1 is 0. This one is x is negative 2/3. And this one is x is a quarter. Alright, this last one. And this was my reminder back here. In both cases, look for perfect squares to save some time. I notice that this is a 25 and that's a 9. So I would guess 5x plus 3 and 5x plus 3. And I would check to see if it works. I get a 15x and a 15x, they add up to a 30x. If you miss that, that's okay. You do the factoring by grouping like we've been doing, but you can see, if you recognize that, how much time it saves you. So watch out for that. That does not happen very often, but when it does, when you got squares on each end and that works, it's a wonderful time saver.